So you've had some practice with manipulating trigonometric expressions. So now that'll lead us to what we call verifying trig identities. So the difference here is we have an equal sign, not just an expression. But notice the question mark. Put an arrow here. So we're not saying that this side is equal to this side. We're not saying that this equation is true. We're trying to prove that it's true. So I can't do algebraic operations on this equation as if it were true to start with. So I can't add stuff to both sides or multiply stuff to both sides. What I'm going to need to do is pick one of the sides, either one, and try and manipulate using those Pythagorean identities or other trig identities that we know, and get the one side to look like the other side. So that's the goal. So what I'm going to do looking at this is I see that the left side seems a little more complicated, so I have a better chance at simplifying it. And especially since I see the tangent squared, that reminds me of the Pythagorean identity tangent squared plus 1 equals secant squared. And so if I move the 1 to the other side, I can replace this tangent squared with secant squared x minus 1. Now when I look at this, I think the top looks like I could factor it. It's kind of like seeing an a squared minus 1. That's the difference of two squares. So I can factor that, and that would become secant of x plus 1 times secant of x minus 1. How did I know to do that? Practice. I looked at the denominator, and I saw that, and I looked at the numerator and saw a difference of two squares. So I thought I could factor it, and sure enough, you can see now that this 1 plus secant in the denominator will cancel with the secant plus 1 in the numerator. So that simplifies this quite a bit. So now I have secant of x minus 1. Now I'm trying to get this to look like the right side of my equation. And I notice that it's all in cosines. Well, I can change secant to be a cosine. So I'm going to rewrite the secant as 1 over the cosine. And then I have a minus 1. Now I'm also keeping one eye over here on what I'm trying to get, and I realize I have one single fraction. So with this, I'm going to need to combine these into a single fraction, which means I need to change this 1 to have a common denominator with the other fraction so I can combine them. So I'm going to change that 1 to cosine over cosine. So I have 1 over cosine of x minus cosine of x over cosine of x. And now I can combine these, and I get 1 minus the cosine of x all over the cosine of x. And that's exactly what I needed to get it to look like. So now I have proven that tangent squared of x over 1 plus secant is equal to 1 minus cosine over cosine. And so that's the idea of proving an identity. Let's look at some more examples. We just did that one. Let's look at this and think, is there another way I could have done this? Well, what if instead of using the Pythagorean identities, what if I took the left side here and I converted everything to sines and cosines? The tangent squared would be sine squared of x over cosine squared of x all over 1 plus the secant, which I can write as 1 over cosine of x. So this is another technique, is put everything in terms of sines and cosines. Now how am I going to deal with this? Well, first of all, I have a complex fraction, but my denominator, I need to combine those to get a single fraction. So I'm going to change that 1 to be cosine over cosine. So I can add those. So now I have sine squared of x over cosine squared of x all over cosine of x plus 1 over cosine of x. Now, if you remember with a complex fraction, dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to take that denominator fraction and flip it and multiply it by the numerator. Okay. Now where do I go from here? Well, everything is in terms of cosines except for that sine squared. But I remember that sine squared plus cosine squared is equal to 1, my Pythagorean identity. So I can move the cosine to the other side, and sine squared is 1 minus cosine squared. So in my expression, I'm going to change that sine squared to be 1 minus cosine squared. Over cosine squared times the other fraction, cosine of x plus 1. I do notice that I could cancel this cosine here with one of the cosines in the denominator. And I also see that 1 plus cosine squared is a difference of 2 squares, so I could factor that as 1 plus cosine times 1 minus cosine. And then what do I have left in the denominator? I'm making it a single fraction. I have a cosine of x left. It was cosine squared, but I canceled one of those. And then times cosine of x plus 1. And sure enough, that cosine of x plus 1 cancels with 1 plus cosine x. And so I'm left with 1 minus cosine of x over cosine of x, which is what I was trying to prove. And so we're done. So now you'll notice I did this problem 2 different ways. Which way do you like better? A lot of people like to switch things to sines and cosines. But the first way I did it seemed a little quicker and not as much work. So there's usually more than one way to prove a trig identity. And once again, practice is the only way you're going to figure out what's the best way for you. So let's look at this one. Let's verify the identity tangent plus cotangent equals secant cosecant. Well, we look at this and we think, gosh, we have 4 different functions here. Somehow I'm going to need to make things look the same. So let's try that technique of putting things in terms of sines and cosines. And so let's take the left side, and by the way, you could work with either side. The left side though, because I'm thinking the secant is 1 over the cosine, and the cosecant is 1 over the sine. And that's pretty simple. So maybe I can put the left side in terms of sines and cosines to get that. So I'm going to change tangent to be sine of x over cosine of x. Plus, and then cotangent is cosine of x over sine of x. Now I can't add these together because they don't have the same denominator. But what I can do is multiply the first fraction by a form of 1, sine of x over cosine of x. Oops, I'm sorry. Sine of x over sine of x. And then I can multiply the second fraction by cosine over cosine. And now both of these fractions will have the same denominator. The denominator for both of them is going to be sine times cosine. And what am I going to have in the numerator? Well, from the first 2 fractions here, I'm going to get a sine squared. You might see what's going to happen here. And then with this fraction, I'm going to get plus a cosine squared. And we know that sine squared plus cosine squared is equal to 1. So I have 1 over the sine of x times the cosine of x. And if I want, I could split that into 2 different fractions. That's 1 over the sine times 1 over the cosine. And I'm running out of room here. But 1 over the sine is the cosecant. And 1 over the cosine is the secant. And that's what I was trying to prove. So I have shown that tangent of x plus cotangent of x equals secant cosecant. Like I said, there's more than one way to do these, so you may want to try your hand at these. All right, the second one on this page, let's verify this identity. Now, obviously, it's clear which side is more complicated. We can see that the secant squared minus 1 over secant squared is probably the one we're going to try and simplify. So there's more than one way to do it. We could change our secants to cosines, but I noticed that this comes from the Pythagorean identity that tangent squared plus 1 equals secant squared. And with the 1 moved to the other side, secant squared minus 1 is equal to tangent squared. So the numerator I can change to write as tangent squared of theta. And then I have secant squared of theta in the denominator. Now, if I want, I can split that up, and I can think of it as tangent squared over 1, or sine squared over cosine squared. And then the secant squared is 1 over the cosine squared. And remember, complex fraction, dividing by a fraction is the same as multiplying by the reciprocal. And in this case, the cosine squareds cancel, and all I'm left with is sine squared. And that's exactly what I was trying to get on the other side of my equation. So I've verified that identity. All right, let's look at one more example. Let's verify this identity. So what's our choice here? We could work with the left side, or we could work with the right side. So you might think, well, maybe I should change the left side to sines and cosines and work with that. But just for a change, let's work with the right side. And here's a common technique that's useful sometimes. Notice I don't have any fractions on the left. So maybe if I take the cosine over 1 minus sine and multiply by the conjugate of the denominator. What if I multiply by 1 plus sine of x over 1 plus sine of x? Now, if I distribute in the numerator, well, actually, I think I'm going to leave it for now. Let me have cosine of x times 1 plus sine of x. In the denominator, when I multiply these, let me show you. It's kind of like saying 1 minus a times 1 plus a. And if you distribute, or FOIL, the 1 times the 1 times the sine, the negative sine times that, negative sine times that, you're going to wind up getting the difference of 2 squares. And so we're going to get 1 minus sine squared of x. But that should make you think about sine squared plus cosine squared equals 1. And so that Pythagorean identity I can use, and I'm going to replace this with cosine squared. So now I have cosine of x times 1 plus sine of x. And now you see why I decided not to distribute that, because I was thinking a step ahead. And now I'm going to be dividing by cosine squared of x. And since I left the cosine factored out in the numerator, this cosine will cancel with one of those. So what do I have? I have 1 plus sine of x over cosine of x, which I can split up into 2 separate fractions. So that's 1 over cosine plus sine over cosine. And 1 over the cosine is the secant, and sine over cosine is the tangent. And voila, we got exactly what the other side is, so we have verified this identity. So as you can see, there's a lot of different approaches. There's a few common techniques that I've been using. So here's a few helpful hints to work through this. Usually it's easier to work with the more complicated side and simplify that to get it to match the other side. Sometimes it helps to convert everything to just sines and cosines. It's usually a good idea to combine fractions by getting a common denominator. Look for squared terms, especially a sine squared or a cosine squared or a tangent or secant squared, and then use one of those Pythagorean identities. And you may need to rearrange the identities to get what you need. For example, the sine squared plus cosine squared is 1. But if we move the cosine to the other side, then we have an expression for the sine squared, or vice versa. Factoring is usually a good idea, and especially look for difference of two squares, and then you'll be able to cancel some factors. So those are the most common techniques used. But the best way to get good at doing identities is to practice.